Hello, grades of. Welcome to this session. It's session 1, and today I just want to introduce to you this new sessions for the topic Euclidean geometry, and this is Euclidean geometry for grade 12, and this is our session 1, and today we're going to be focusing on proportionality theorem. Okay, let's take a look at the content outline. And this is just showing you what we will do in all these sessions. As you can see in your Platinum Mathematics Learners book, the book that we will be using, and also Mind the Gap Mathematics Study Guide. It's also the textbook that we're going to be using. And if you take a look at the one above, the outline there, 12.2, it's proportionality theorem, and this was taken from Mind the Gap Mathematics Study Guide. And also, if you take a look at Unit 3 of Learner's book, Platinum Mathematics Proportionality Theorem, page 221. It's also a focus. So I'm very sorry about the background noise. Yeah, so that's just the content outline, and we're gonna be focusing on proportionality theorem. Not only focusing on proportionality theorem because it does not go alone, to put it that way. So proportionality theorem has a converse theorem. We'll also take a look at the converse theorem of proportionality theorem. We are also going to take a look at one of the related theorem with proportionality theorem, and it's just a revision, and that's midpoint theorem and its inverse, and also extracting different examples from these two textbooks and also from some past papers. Okay, before looking into proportionality theorem, it's very important for us to look at some key basics that will help you to understand proportionality theorem the time I'll introduce it to you in this session. So we have to revise proportion and areas of triangles. So these are the two key basics that you need to know, so that it might be easier for you to understand proportionality theorem. Okay, so firstly, you must be able to know what is a ratio. What is a ratio, right? So we know that ratios compares two measurements of the same kind using the same units, right? So that is a ratio. If we want to compare two measurements, for example, I might want to compare the height of two learners, right? I just take two learners and I want to compare their height, right? So I want to compare two measurements, which is like their height of the same unit. If it's in meters, both heights must be in meters. So there I would actually want to get what? To get the ratio. So that is what we mean by ratio. It's just it's a measurement that compares two different items but that have the same units. Okay, so an example is if line A is 2 units long. Okay, here we have line A, given that it's 2 units long, so this is the distance, right? It's the length, not the distance, sorry, it's the length. So, and we have line B, which is what? Which is 6 units long, right? Then if we want to compare these two lines, and we'll definitely get their ratios, right, in order to compare them. So we are saying line A is to line B will be 2:6. So we are saying line A is to line B, that is their ratio, will be 2:6. And this is the same as 2/6, or you can write it in that way, 2:6, or you can write it as 2/6, which will definitely give you 1/3. And if we write this as a ratio, we'll just say 1:3. I'm really sorry about the background noise. I'm just somewhere where it's quite noisy and children are just playing on the background there. Sorry about that. Okay, so 1/3 can also be written as 1:3, right? So this is the same ratio as 1:3. So if we have 2:6, we know that is the same ratio as 1:3, right? Okay, let's come to these other lines. So line C is 1 unit. You are given that line C is 1 unit and line D is 3 units, right? So line D is 3 units. So if we want to calculate its ratios, line C is to line D, it will give us what? 1:3, because the length of line C is 1 and the length of line D is 3, so it's 1:3, right? So we can now see, look at this, we can now see that line A and B and line C and D have the same ratios. Can you see? They have the same ratios. They have the same ratios, right? So if they have the same ratios, we can now conclude that they are in the same proportion. That's where proportionality comes in now. So if two kinds of the same measurements are in the same ratio or have the same ratios, then we can conclude that they are proportional or they are in the same proportion. So you can see that proportionality is related to ratios. So if we calculate the ratios and find that they are the same, then we can conclude they are proportional. So the two ratios are equal, as they've indicated also here, and we can say that A over B, because it's line A is to B, so we can write it as A over B is equals to what? It will be equals to C over D. A over B is equals to C over D. And we can say that A, B, C, and D are in proportion, just as I've said. A, B, C, and D are in proportion. So this proportion can be written in many ways, right? One can say A over B is equals to C over D, or one can just say A over C, or you can choose to say A over C. Then you will say is equals to B over D, right? So you follow that same sequence. So someone can just decide to say, I'll start with B, and you'll say B over A, then you'll say is equals to what? D over C. So you must follow that same sequence. Or someone can just say C over A, then you'll say, as you can see, C over A, then they start with C followed by A, then you'll follow D over B, D over B. So those are the many different ways in which you can write that proportionality there. Okay, great stuff. Let's focus on the second key basics that you need to know in order to understand proportionality theorem, and you'll begin to understand proportionality theorem very much better after we finish with this basics. Okay, so the first one says, if two or more triangles lie between parallel lines, they have the same altitude. Okay, so if you have two or more triangles that are lying between the same parallel lines, right, that are lying between parallel lines like that, it means that their height also, they're the same, right? So the height there, if I name this height 1, will be the same as height 2 there. Even if I come here and I maybe sketch maybe another height here, it's still the same, height 3. So throughout parallel lines, in between parallel lines, the height is still the same. So we have the same altitude, the same height, right? Okay, so number 2, triangles on the same base. So triangles on the same base or equal bases and that are found between parallel lines have equal areas. What do we mean? So if we have triangles like the picture that I just put here, we have triangles, right, that share the same base. Okay, let me highlight them for you. We have triangle ABC. Take a look at triangle ABC. Here is it, right? So this is triangle ABC, right? And we also have triangle what? ABD. You see ABD. They are found between parallel lines. It means that they have the same height, right? And also they are found on the same base. They are sharing the same base. AB is their base. Is a base for triangle ABC, and it's a base for triangle ABD. So it means that also their areas is going to be the same, right? It's going to be the same. Why? Because we know that area of a triangle is what? Area is 1/2 base times height, base times perpendicular height, right? So if the height is the same and the base is the same, obviously the area is going to be the same. And what will be the reason? Same base and same height. And also we might have to indicate for them that they are found between parallel lines, just for them to understand where you're taking that same height. It's because they are found between parallel lines. For example, here they just show you clearly that area of triangle ABC, it will be 1/2, its base is AB times height, right? Because height is the same throughout, times height. So area of triangle ABD, it will be 1/2, its base is still AB times height, and its height is still the same there. So we can see that these two areas are the same because they have the same base and same height. Then area of triangle ABC will be equal to area of triangle ADB. And the reason that we're gonna give is because they have same base, same height. And also you might want to indicate for them that also they are lying between parallel lines, to say CD is parallel to AB. So that's the reason that you can give. So these are just some key basics that you need to know before we start introducing proportionality theorem. Okay, let's now go to proportionality theorem and let's see how this can be useful. Okay, most important part of our session, proportionality theorem. And know that every theorem you'll need to know how to prove it, because for examination purposes they may ask you to prove this theorem. They can just give you this triangle and they say prove the theorem which state this, right? So any theorem, they have a statement and a proof, right? You must provide a proof. You don't just provide a statement. Prove what you are telling us. So in the examination, you need to learn this proof for the examination purposes, in case they may ask you to prove it. Okay, so what is its statement? What does proportionality theorem state? So proportionality theorem state that if a line is drawn parallel to one side of a triangle, right? So if a line is drawn parallel to one side of a triangle, and we can see this line is drawn parallel to one side of a triangle, which is BC. It's only drawn parallel to BC, right? DE is drawn parallel to BC. Then that line is going to divide the other two sides in the same proportion. Very, very simple. So you can realize now that those key basics are very, very important for you to be able to come up with a mathematical representation of these words, right? So they're saying if a line is drawn, here's a line is drawn parallel to one side of a triangle. It's only drawn to one side of a triangle. Look at the bigger triangle ABC, right? There's a line in between, that is DE, that is drawn parallel to one side of a triangle, of that triangle. So they're saying that line, it will divide the other two sides in the same proportion. What does it mean? We already talked about proportion. When we say that line, it will divide the other two sides in the same proportion, it means that the ratios of these two sides will be the same. In other words, you will find that AD over DB, which is the ratio of this side, I'm saying AD over DB will be equals to what? It will be equals to AE over EC. So you can see now their ratios are, the two sides are in the same proportion because there's a line that divides them and it's parallel to the other side of a triangle. So that's basically what this theorem states, right? So the reason for that, if you say AD over DB is equals to AE over EC. You are now telling them that, okay, their ratios are the same, meaning the lines are in the same proportion. So the reason that you give for this theorem is that proportionality theorem. You can just write prop theorem, then you also indicate which lines are parallel, DE, because DE is parallel to what? To BC. So that's the reason that you give to them. Okay, let's now prove this theorem, right? Let's now prove really if whether it's true what they are telling us, that if there's any line that is drawn parallel to one side of a triangle, it will divide the other two sides in the same proportion. Let's prove this, right? So the given statement here is that on triangle ABC, with D on AB, we have D on AB and we have E on AC, we are given that DE is parallel to BC, and we can see it from the triangle there. We are given that DE is parallel to BC because the statement say if a line is drawn parallel to one side of a triangle. So that's a given statement. DE is parallel to BC. What are we supposed to prove? We are supposed to prove that indeed the two sides are in the same proportion. It means indeed that line that is drawn parallel to one side of a triangle to divide the other two sides in the same proportion. In other words, we are supposed to prove that AD over DB will also be equals to AE over EC. Oh, I'm sorry about the background noise. It's quite irritating, but that is what we are supposed to prove, right? That indeed if there's a line parallel to one side of a triangle, then that line will divide the other two sides in the same proportion. That is to say, AD over DB will be equals to AE over EC. Okay, let's take a look at the proof now. How do you prove this? So before every proof, you have to construct, right? You start with the construction, and the construction for this proof is just for you to construct a line, two altitudes, right? So you construct two altitude in triangle ADE, right? So you just need to construct two altitude H. So I'm just gonna show you. This is my altitude H. I'll name it H, and also construct another altitude, that is altitude K, right? So in that triangle, so another altitude K. So that's how you do it. Construct two altitude K or altitude H. So you might name them. Some people might prefer to call it H1, H2, but I'll just use H and K. Okay. Then you have to join DC and BE, and this construction must be there in your your paper. You must show them that, okay, this is what I'm doing, and you tell them I'll join DC and BE. So we join these two lines, DC and BE. That's it. So that's the construction that you make when you want to prove proportionality theorem. Okay, let's go to the proof now. So for us to prove, don't forget, we want to prove that indeed the sides are in the same proportion. In other words, we want to prove that AD over DB will be the same as AE over EC. We want to prove that indeed their ratios are the same. So how do you do this? Now you have right angle triangles in this smaller triangle here. Look at this smaller triangle, right? So what you do really is you go and find the ratio between that this smaller triangle here and one triangle this side, right? So you just find the ratio between those two triangles, the ratios between their areas. So in other words, you are going to say area of triangle ADE, that is ADE is this one, is this smaller triangle here, over area of triangle DBE. So we want to get the ratio between the two areas. So why are we choosing ADE and DBE? Why are we not choosing maybe DEC, and we just want to choose those ones that are sort of like corresponding in that sense? We are doing it so that we can get really the ratios between these two sides, right? Remember, we want to prove that this side over this side will be equal to this side over this side. So hence, the first thing you do, you just find the area of this triangle and also this triangle, so that because those two triangles, they have these sides, right, that we need. So that's why we use them. Okay, so area of triangle ADE will be equal to what? 1 over 2. What is the base? The base is AD, right? Because we want to get this side, the base is AD. If we choose that base, then we're gonna multiply it with what? With the perpendicular height, with it, which is h. So it will be 1 over 2 AD times h over, let's come to this triangle here. Its base is what? Is dB. As you can see, there is dB, but its height is still this one. You see, it's still h. Also, it has that same height there. So it's h. So if you notice, 1 over 2 and 1 over 2 will cancel with 1 over 2, h will cancel with h, and we'll be left with AD over dB because they have the same altitude of h. H and h will cancel. Okay, we just calculated the ratio of those two triangles, and that way corresponding, so that we can get these sides, right? And we got them there. So what you do also in the second step, you go and calculate the ratios of the areas of these two triangles, this side, that are related this side, right? Okay, let me just delete so that you can clearly see properly without these things. So here we had constructed DC and BE. Okay, maybe I can use a different color. Okay, so we want to get now the area of the ratios between triangle ADE and also triangle DCE, this side, so that we can get these sides, right? So we use those two triangles. So area of triangle ADE will be 1 over 2. Because I need this side, I will use this base AE times what is its height there. Its height is k, right? Its height there is k, so I name it k. So it's 1 over 2 times base, which is AE times k, right? As you can see there. Okay, as we move for this triangle now, the area will be 1 over 2. Its base is what? Is EC, and its height really is what? Is k. Its height there is k. So then, because k and k, they have the same height, k and k will cancel, 1 over 2 will cancel, and their ratios will be AE over EC, AE over EC. But there's something very, very important. Okay, let me just erase these green lines. Let me see if this is possible. Okay, much better. Okay, but there is something here. Take a look at triangle DBE, right? And again triangle what? DCE. They are found between parallel lines. Can you see? Triangle DBE and triangle DCE, they are found between parallel lines, and they share a common base here. They share a common base here. They share a common base. Can you see? This one that I just highlighted here, they share a common base. What does it mean? We said that if triangles are found between parallel lines, remember the key basics, I told you they're going to be useful. If triangles are found between parallel lines and sharing the same base, it means that their areas are also equal, because they have same base and same height, because they are found between parallel lines. So then we can conclude that the area of triangle ADE, the area of triangle ADE, I think they just made a mistake here because it's not ADE but it's DBE, the area of triangle DBE, DBE. I don't know why they made such a mistake. The area of triangle DBE, supposed to be DBE. The area of triangle DBE is this triangle. It will be equal to the area of triangle CED. Can you see? CED, because they have same base DE and they have same height. Because they are between parallel lines, we know that the height or altitude is the same, and also you have to show this reason that because they are also found between parallel lines, right? So that's it. Therefore, now you can see that the areas of these triangles under DBE and triangle CED are equal. It means that the whole thing will be equal. For example, if I have something like x over 2 is equals to y over 2, because these two under are equal, or let me just write them separately so that you may not get confused. X over 2 and I have y over 2. From these two ratios, we can see that the base are equal, right? I mean the denominator are the same, they are both 2. Then we can also equate the whole equation to say x over 2 is equals to what? Is equals to y over 2, because the things under are equal. If the denominators of two ratios are equal, it means also the numerators will be equal, and if you cross multiply, you realize that was correct. Okay, so also in this case, because the areas under there, they are the same, then we can equate the whole thing to say area of triangle ADE over area of triangle BDE will be the same as area of triangle ADE over area of triangle CED, because those areas under there, they were the same, they are equal because they are found between parallel lines and they have the same base and ultimately same height. So after equating the two, you realize that here is it. We have now proven that AD over DB is equals to AE over EC, because area of triangle ADE over area of triangle BDE was AD over DB. We already calculated it and we found AD over DB. Area of triangle ADE over area of triangle CED was AE over EC, meaning to say that really it is true that if a line is drawn parallel to one side of a triangle, it will divide the other sides in the same proportion. Let me just erase these things here. So it will divide the other two sides in the same proportion, meaning to say we can say AD over DB will be equals to AE over EC. Don't forget, this proof is very, very important and you need to learn it for your examination, because they can just give you a triangle and they say prove these things. In other words, they are saying prove that the sides are in the same proportion, right? So you need to know how to prove this, and it's very simple. You first construct the altitude in the smaller triangle. After constructing the altitude on that one that looks like a I think it looks like a trapezium or something, you then join the lines there. Then after joining, then you can now calculate the areas of those corresponding triangles and you get their ratios. You realize that those areas that are between the parallel lines, right, will be the ratio. The areas in your denominator will be equal because they are in between parallel lines and they have the same base, meaning to say they also have the same height. Then we can equate them and you can just prove this theorem. Line drawn parallel to one side of a triangle divides the other two sides in the same proportion. Okay, let's now look at different examples. Okay, let's take a look at this example. It says determine the value of x, and this is just an example that I just put here so that you may be able to understand proportionality theorem calculations and all those statements, just bringing them into some practical way. Okay, so you are given a diagram and they say determine the value of x, and you can see that your value of x is the length of QC, right? Is the length of QC. And you have AP, which is equals to what? Which is equals to 5 centimeter. And you have PB, which is equals to 3 centimeter. You're also given AQ as 4 centimeter. And what can you see from your diagram? How can you solve for x? From the diagram, we can see that PQ is parallel to BC. It means that in this triangle, there's a line drawn parallel to one side of a triangle. And what do we know? It will divide the other two sides in the same proportion. Therefore, we can equate their ratios to say AP over PB is equals to AQ over QC. And what will be the reason is proportionality theorem, and you also indicate which lines are parallel. It's because QP was parallel to BC. So that is your reason, right? It's proportionality theorem, and we just showed them because PQ was parallel to BC. Okay, then we can go and substitute 5 centimeter as AP, 3 centimeter as PB, AQ was 4 centimeter, and we want to determine the value of x, right? So we'll have something like, if we cross multiply, then we'll have 5 centimeter multiplied by x is equal to, oh, sorry about this, it's sort of like not 5 centimeter multiplied by x is equal to 3 centimeter multiplied by 4 centimeter. So to solve for x, we're just gonna divide both sides by 5 centimeter. Divide by 5 centimeter. This 5 and 5 cancel it out. X will be equals to 3 times 4 is 12 centimeter squared divided by 5 centimeter, right? So it's just gonna be 12 divided by 5, which is 2.4. So 2.4 centimeter will be equals to x. So that's basically what you do. So it's just a simple example just to enhance your understanding in proportionality theorem. Okay, let's now take a look at this different example, example 2. And I just want you to learn something from this example. Okay, so you are given ED and G are points on AC and BC of triangle ABC, such that GE, we can see GE is parallel to BD, and we can see that AG intersect BD at F, like that. And let's focus on this given information. Very, very important. You are given the ratio of line BG over GC is equals to 5/2. So what does this mean? Okay, so someone might think, okay, it means that BG was 5 and GC was 2. Not really, not correct. So this is a ratio, right? So when you're given like that, so because it's a ratio, there might be something that ratio was, that number given in the ratio was being multiplied with in order to get the actual length. Remember, ratios are just comparison, where we're just comparing two things. For example, you might find that the length of BG was maybe 10 centimeter and the length of GC was maybe 4 centimeter. And when you take 10 divided by 4, you'll still get 5/2. Or you might even get something else, the way something else. So really, to be sure, if you are given such a ratio like that, BG over GC is equals to 5/2, you have to take that number and you multiply it with a certain variable which is unknown, which we can calculate if you want. Okay, so where there is BG, I'm just gonna write 5x, right? Because the length of BG is 5x. We don't know which variable they might be multiplying it, that 5 in order to get the actual length of BG. Okay, GC also, we're just gonna write 2x, and if you take 5x divided by 2x, x and s will cancel and the ratio is still 5/2. But for the actual length, you have to show it as if you are multiplying with another variable. Okay, same as this one, AD over DC is equals to 3 over 7, right? So it means that also for AD, I'm just gonna write 3, but I can say 3x because x we already use it on this side, right? So the variable x we already use it on this side. When you move to the other side, you just change the variable and use a different one, right? So AD, I'm just gonna indicate it as 3y and use variable y there to show that the length of AD was 3y, just to say they were multiplying with y, which is our unknown variable, and we can actually calculate it if we're given enough information. Okay, DC is 7 there as its ratio, then my DC here is gonna be 7y, right? Okay, so now after doing that, we can go and calculate these questions. Okay, 1.1, it says determine AF over FG. Determine AF over FG, right? Let's take a look at AF. Look at the green line there, right? AF over FG. It's found on that small triangle there. Maybe let me highlight it also with a green line just to show you. Look at this triangle here. We have our AF here over FG, and it's on that small triangle, and we can see that on that small triangle there's a line drawn parallel to one side of a triangle. Look at this blue line, right? Look at this blue line. It was parallel to this. It means that also here, this line here is still parallel to this side, right? It's still parallel to that side. So it means on that smaller triangle there's a line drawn parallel to one side of a triangle. Then we can use what? Proportionality theorem. And how can we use proportionality theorem? It will say AF over FG is equals to what? Is equals to AD over DE. And what is our reason? It's proportionality theorem. And we can also show them which lines were parallel, because FD is parallel to what? To GE, right? Because FD is parallel to GE. So in order to get AF over FG, we need to know what is our AD, right? And our AD is already there, is 3y, right? Our AD is 3y. So what we are left with is to calculate what? DE, is to go and calculate DE. Then after getting DE, we can get the ratio of AF over FG. Okay, let's go and calculate DE, right? Take a look at DE. So this is quite challenging, but it's very simple. You just need to identify the triangle in which your D is found on, right? Where you can apply proportionality theorem. So if you take a look at your DE, it's here, right? So if we go with this one and we go like this, you can see there's a triangle here and there's a line drawn parallel to one side of a triangle, like that, right? So this line GE is drawn parallel to one side of this triangle, which is BD, right? So it means that we can use proportionality theorem to solve for DE. Okay, so I'm just gonna say DE over, because I want to get DE over, what do we have on that side of triangle? What do we have? We have the whole of DC. We don't have EC, so we can't say DE over EC because we don't have EC, you see. So we have to say DE and what we have on that triangle, which is what? Which is the whole length, which is DC, which is 7y. So I'm just gonna say DC. DE over DC is equals to what? Also this side will just say BG, because we had said DE over DC. This side also we must say BG will be equals to BG over BC, the whole of it, because also that side we took the whole of it. Okay, so let's go and substitute, and we must give a reason, obviously, because of proportionality theorem and because we can see BD is parallel to GE. So that's our reason. Okay, so let's go and substitute and solve for our DE. our DC is 7y is equals to BG is 5x, and BC, the whole of BC here, we're gonna take 5 plus 2, right? So it's gonna be 5x plus 2x, right? So in order to solve for DE, I can just simplify that one to say it's 5x over 7x. Then this x and this x will cancel each other, right? Then I can cross multiply to solve for my DE. Then when we cross multiply, our DE will be equals to 7y multiplied by 5 over 7. Then this 7 and 7 cancel out each other. DE is equals to 5y. Very good. DE is 5y. Then we can now get our AF over FD. We now replace our DE there. Then we can get this ratio. So it's going to be 3y over 5y. Then this y and y cancel out each other. Then we're left with 3 over 5. 3 over 5. So that 3 over 5 is the ratio for AF over FG. AF over FG. So you can see it's a matter of identifying where our length are located, like on which triangle in which we can apply proportionality theorem. Immediately when you see lines drawn in between triangles that are parallel to each other, you must think of proportionality theorem, and you can actually get all those. Okay, let's now focus on 1.2. It is now saying determine the area of triangle AFD, that is the smaller triangle. Let me just highlight it there. I'll just color it with green there, just filling it with green. AFD over area of triangle AGE, that is like the bigger one, the AGE, this one. Okay, so they want the ratio of these two triangles. How do you get the answer for this? So now you must know area rule, the one that you learned in grade 11, right? To say if you want an area of a triangle, you can just say 1 over 2 this length times this length, multiply sine angle that is included, or that is inscribed by those two lengths. For example, if I have a triangle like this ABC, from area rule, if I want the area of this triangle, area of triangle ABC, so I can see it's 1 over 2 multiplied by, if I take AB, length AB multiplied by length AC, then multiplied by sine angle A, because I'm taking this side and this side, then I must take the angle that is included, the sine angle A. Okay, sorry about this, sine angle A. So that will be the area. Or someone can say area triangle ABC is equals to 1 over 2. If you choose to use this length BC multiplied by maybe AC, then you'll have to multiply also with sine angle that is formed there by those two sides, so sine C, like that. Someone can choose to take AB and BC, then you'll say sine angle B. So that's basically the area rule. Okay, let's get to this one. They say find the area of triangle AFD over area of triangle AGE. AFD is that smaller triangle that I've colored with green there, right? And over area of triangle AGE. You can see that those two triangles are like on the same, what can I say, on the same plane or something like that. They're like connected, right? AFD is that smaller triangle, AGE is that bigger triangle. So if you want to get this area like this, what you can do is when you say sine angle, when you want to use area rule, you must choose the angle that is the same between the two triangles, right? In other words, I'm saying for area of triangle AFD, we are going to say 1 over 2 multiplied by this side, which is AF, multiplied by this side, which is AD, then multiplied by the sine angle that is included there, which is A, right? Also, for this bigger triangle, we're just gonna use the same style. We say AG, right? If you check the bigger triangle there, we're just gonna say for this one, area of triangle AGE, we're gonna say 1 over 2 multiplied by AG, multiplied by also this side, which is AE, then multiplied by the sine angle that is included. Is still the same as what is that one above, with this sine A. Why do we do so? We want this angle and this angle to cancel like that. Sine A cancel, 1 over 2 and 1 over 2 cancel out each other. Then we can replace our AF was 3p, I just use it at 3p there. Remember, we calculated AF over FG to be 3 over 5. So because it's the other side, we can just use another variable to say p like that. So AD is what? AD is 3y. So to multiply with 3y over AG is this bigger one. It will be 3p plus 5p, which is 8p, multiplied by AE is that other one, which is 3y plus 5y, which is 8y, right? So like that, p and p cancel out each other, y and y will cancel out each other. We are left with 3 times 3, 9, 8 times 8, 64, right? But this one, I think we can simplify it. 9 divided by 64, it's just gonna be 9 over 64. So that will be the answer of the area of triangle AFD over area of triangle AGE. So you must know the sine rule, but while applying this sine rule, just know that ensure that you use the same angle so that they can cancel out each other. So if the triangles are connected, right, like these ones, you just ensure that you choose the sides that will enable you to use the same angle so that those angles may cancel out each other. Then you can just simply get your ratio there, 9 over 64. Okay, let's take a look at a different example, and I'm just putting this different examples so that you may just conceptualize this theorem and you may be able to solve different problems if expected to use it. Okay, they said in the diagram you are given that RF is parallel to KG and ED is parallel to KH as indicated in the diagram. And we are given that RH is equals to 3 units. So here you don't have to write it like 3x as in like you're multiplying with a variable, because here they just give you the actual length. It's not like a ratio, right? So RF, I'm just gonna write 3 because that length is 3 units there. RK, it's 9 units. Then for RK, I'm just gonna write 9. HF is 2 units. For HF, I'm just gonna write 2. So here is your ratio. You are given that GE over EK is equals to 1 over 3. 1 is to 3 is the same as 1 over 3. So this does not mean that the length of GE is 1 unit, right? So that's where you have to multiply with an unknown variable, because that's a ratio. It shows that they were multiplying with an unknown variable to get that actual length. So to be 1 times x, I can just write x, right? For EK, 3 times x, can just write 3x, just to show that the length of this one is not 3, but there's another variable that we need to multiply with to get its actual length. So that's what you do when you're given ratios. Okay, now let us go. They said calculate stating reasons the length of the following. 1.1, they need the length of FG, the length of FG. So take a look at your FG. Your FG is this length, right? They need this length of FG. So if you are just given triangle and you see lines parallel to one side of a triangle like that, you must think of proportionality theorem, because it states that if a line is drawn parallel to one side of a triangle, then that line will divide the other two sides in the same proportion, right? So that's why you have to think of proportionality theorem when you see lines drawn parallel to one side of a triangle, in a triangle like that. Okay, so if you check here, we have these two triangles, many triangles actually. So you must know which one you're gonna use, right? Your FG, it's this length here. So, but if you can trace this bigger triangle like this, like that, you can see that if it's easier to use this one, that is like RF is parallel to what? To kg, right? So because we can easily calculate the length of FG. So if we just get the ratio between this side and also this side, then we can just get the length of what? Of FG. So you must be able to identify it like that. Okay, so to get the length of FG, we can use what? We can say HR over RK is equals to HF over FG. Then we can, our reason will be proportionality theorem. Okay, and we also have to indicate that RF was parallel to kg. Then let's substitute HR was 3 units, RK it was 9 units, HF it was 2 units. Then we can solve for FG by cross multiplying. When you cross multiply, you get 3FG is equals to 9 times 2, then divide by 3, then divide by 3. Then when you calculate your FG, it's going to be 18 divided by 3, which is going to give you 6 units. Okay, so your FG is 6 units. So we have calculated our FG 6 units using the proportionality theorem, because we saw that our FG is on this triangle where there's a line parallel to one side. Then we can say the sides, the other two sides, then are divided in the same proportion. Then we get and cross multiply and get the answer. Okay, let's now move to 1.2, and our 1.2 here requires us to calculate what? FD. They need FD, right? So let's check our FD. Can you see your FD is this small portion here, right? So in order to calculate FD, you can see that we can identify a triangle in which you can use proportionality, but FD itself alone, it does not form that part of that triangle. That it just forms part, but it does not complete it, right? So if we extend to go there, HD, you can see if we go like this, we can see there's a line drawn parallel, and we can use proportionality with HD like that. So let's see, we're gonna use that proportionality HD over, let's check what we have. We have HD. So why are we choosing HD? It is because if we choose HD, we know that HD is made up of HF and FD, right? So but HF is already 2, then it can be easier for us to calculate what? FD, like that. Okay, so we have HD over what we have in that whole triangle. If you check, we have a length from here to here, which is 6 units, and we also have a length from here to here, which is 2 units, right? Or let me indicate it properly. It's 2 units there, right? So you can see that what we can also use a proportional for the whole one, which is 2 plus 6, which is 8 units. Can you see? So we're gonna say HD over HG. That is the whole length, because we have it's 2 plus 6, which is 8 unit, right? Also, we're gonna do the same this side, because we're using this proportionality here, these parallel lines. Don't forget, we're gonna say KE is gonna be equals to KE over the whole length, as we did that side, which is KG, right? And this is by proportionality theorem, and because you can see that HK is parallel to DE. HK is parallel to DE. So let us substitute our HD. It is 2 plus FD. Can you see HD? It's just that it's a bit of a mess here, but if you can check properly, HD here, HD, it is 2, this 2 here, plus HFD, like that, over HG is the whole length. It's 2 plus what? Plus 6. It is that 2 there plus 6. So which is 8 units. Then KE, it was 3x. You can see it was 3x because of this proportionality there, ratio. Then if we just write it in a fraction, you will see it that indeed EK or KE is 3x. Then over the whole one here, which is KG, which is 3x plus x, which is gonna be 4x, right? So x and x will cancel out each other. We can cross multiply. Then we'll have 2 plus FD multiplied by 4 is gonna be equals to 8 times 3, right? We can now solve for what? For your FD by dividing both sides by 4. We can divide both sides by 4. Then this 4 and this 4 cancel out each other. We'll have 2 times 3 gonna be 6, right? So we'll have 2 plus FD is gonna be what? It's gonna be 6 equal to 6. If you say 8 divided by 4 is 2, 2 times 3 is 6. Okay, so to solve for FD, we're just gonna take 2 to the other side, 6 minus 2, and our FD will be equals to 4 units. You can see your FD now is now 4 units. And how did we solve it? Let me just repeat this because this was kind of a tricky question, and you really need to understand how we approach this, right? So how we approach this is that we checked because the question wanted FD, right? FD. So but because we can see that there are lines drawn parallel to side of a triangle and all that, so we need to think of proportionality theorem. But we saw that, okay, our FD, it's on this line, but if you can extend like this so that it can enable us to use proportionality theorem here, because there's parallel lines here, there's parallel lines, you can see, right? So if we extend it to get this ratio over the whole one, because we had the whole one, also this ratio over the whole one, then we just substituted and solve for our unknown there. So it was 4 units. Okay, let's now quickly look at the converse proportionality theorem. Okay, I just wrote proportional theorem, it's fine. Okay, converse proportionality theorem or proportional theorem. So this is the converse of proportional theorem, right? And you know that the converse now, it's just like the theorem itself. It's just that the converse now starts with what we had to prove in the theorem and goes back to the given information. Sort of like it's repeating the theorem from its ending point to its beginning. Okay, so the converse goes like, if a line divides two sides of a triangle proportionally, right? If a line divides two sides of a triangle proportionally, then that line is parallel to the third side. That's it. So remember, the theorem itself stated that if a line is drawn parallel to one side of a triangle, then it will divide the other two sides proportionally. But then the converse now is sort of like starting at the end of the statement to say, if a line now divides the two sides of a triangle proportionally, and then that line will be parallel to the third side. And the reason that you will give for this converse theorem is that the line divides sides of triangle proportionally, right? Because if a line is drawn, okay, like this line DE, it is drawn, and if this line is dividing these two sides of a triangle proportionally. What do we mean when we say proportionally? We mean the ratio of the sides are equal, right? Then that line is going to be parallel to the third side. So that's the theorem. So the given information here is that the two sides are in the same proportion, right? In other words, we are saying BD over DA is equals to what? CE over what? Over EA. So if we have like BD over DA is equals to CE over EA, then we can conclude that DE is parallel to BC. And what will be our reason? Line divides sides of triangle proportionally. Okay, so let's just quickly look at this quick example here, and let's see how it goes. So it says in triangle ABC we have AD, which is equals to 3 meter, we have DB, which is equals to 12 meter, we have AE, which is equals to 6 meter, and we have EC, which is equals to 24 meter. Then they say prove that this line DE is parallel to what? To BC. Very simple. How can we prove that? We just need to calculate the ratio of the two sides and to see if they are equal. If they are equal, we say the sides are in proportion, then that line is parallel to the third side, but the reason line divides side of triangle proportionally. Okay, so let's go and calculate the ratio of the side. So I can say AD over DB, it will be equals to 3 meter over 12 meter, right? So this will be equals to 1 over what? Is it 1 over 4? Let me check quickly. 1 over 4. So this will give me 1 over 4. I've calculated the ratio this side, right? So let's go to the other side and calculate its ratio there. So I'll say AE over what? Over EC. 6 meter over 24 meter. And also this is giving me what? 1 over 4. So I can conclude that therefore AD over DB is equals to AE over EC. Why? Because both of them are equals to 1 over 4. Therefore I can conclude that okay, because the two sides now have the same ratios, it means that they are in the same proportion. Therefore we can conclude that DE is parallel to what? To BC. Then we can conclude that DE is parallel to BC because of the reason line divides sides triangle proportional. Or you can just write Converse proportional theorem, right? As your reason, you can just write Converse proportional theorem. So it's very simple. If you just find that the sides are in the same proportion, then you must know that in that triangle there's a line that is parallel to the third side. Okay, let's also quickly revise midpoint theorem and its converse, right? So I think you did midpoint theorem in grade 9. So proportionality theorem can also be combined with midpoint theorem. They can give you some of the things because it's also sort of like a triangle where there's a line that is dividing two sides of it, right? So they can try to combine proportionality theorem with midpoint theorem and just give you some questions just to make some questions quite tricky and all that. Okay, so midpoint theorem, it states that if a line segment it's drawn and it's joining the midpoint of two sides of a triangle, right? As you can see in this diagram, there is DE that is drawn and it's joining the two sides and it's drawn to the midpoint of two sides of a triangle, right? So if a line segment is drawn to the midpoint of two sides of a triangle, then that line is going to be parallel to the third side, and it's also going to be half the third side. Okay, so the given information here, let me write given. We are given that D is the midpoint of line AB, right? And E is the midpoint of line what? Of line AC. AC. So if D is the midpoint of line AB and E is the midpoint of line AC. So in other words, there's a line that is drawn to the midpoint of two sides of a triangle. So to show that these lines are to the midpoint, you can see that this length here is the same as this, and this length here is the same as that length there, right? So you can see by that line was joined to the midpoint. Then that line, we can conclude that, therefore we can prove that, or we can prove that indeed DE is parallel to what? Then DE is gonna be parallel to BC, and DE is gonna be equals to half what? Half BC. Okay, so that's basically midpoint theorem, the one you learned in grade 9, I think also in grade 11 they taught you midpoint theorem. So basically saying if a line is drawn to the middle of two sides of a triangle, then that line will divide, that line will be parallel to the third side, and also it will be half the third side. So that's basically midpoint theorem. So your reason can just be midpoint theorem. Okay, so if you give this statement to say, okay, I can conclude that this one is parallel to this and this one is half that one. So midpoint theorem. Okay, let us look at the converse midpoint theorem. Quite different, but it's sort of like the same. So this is the converse midpoint theorem, right? It says if a line is drawn from the midpoint of one side of a triangle, right, and parallel to the second side of a triangle, then it is going to the midpoint of the third side, and its length is going to be half the line in which it is parallel to. Okay, so you can see that here there's a line, right, that is drawn parallel to this side, to one side of a triangle, right, and that line, it's also going to the midpoint of that side, right? Then what will happen? That line is also going to what? To divide the other side to its midpoint. That is this side, you'll get it as being the same as that one, and that line will be half that one. So if you just see something like that, just know that you can think of the converse midpoint theorem to say, okay, there's a line that is drawn to the midpoint of one side of a triangle, and that same line is parallel to the second side. Then it will divide the third side to its midpoint, and it will still be half the length of the second side, like that. Okay, so that would be converse midpoint theorem. That is, you are given that PS is equals to SQ, and ST is parallel to QR. What can you conclude? Conclusion. What can you conclude? You can conclude that even PT is equals to TR, then it will also join this other side to its midpoint, and ST will be half QR. So that's our conclusion. So that's just some quick revision on midpoint theorem and its converse. Okay, let's now focus on this example that also combines proportionality theorem and also midpoint theorem. Okay, so you are given a diagram and you are told that P is the midpoint of AC. You can see we have point P. They are saying it's a midpoint of AC. It means that AP is equals to what? Is equals to PC, right? In triangle ABC. R is a point on AB such that RS is parallel to PP, and we can see that. And AR over AB, we have AR over AB is equals to 3 over 5. What does it mean? These are the ratios, right? It does not necessarily mean that the length of AR is 3, but there might be another variable that it's been multiplied with so that it can give us the actual length of AR. So we're gonna put 3x there, and also on AB is equals to 5. So AB is this distance, all of it is 5. So for it to be 5 here, it must be what? 2x. Okay, Then we are given that R intercept PB in T. Okay, so let's go to the first question, 10.2.1. It says determine with reasons the following ratios, AS over SC. AS over SC. Can you check AS is this one? Or maybe I can use a different color. Which one? This one maybe. AS over SC over SC, right? So we want to get AS over SC. Okay, so we can't get AS over AC, that ratio, without knowing maybe what is AS, right? And what is ASC, right? So let's check the triangle, in which maybe we can use proportionality theorem to calculate the ratios of those things. So take a look at this triangle here. There's a line that is drawn parallel to one side of a triangle, right? It means we can use proportionality theorem to get the ratio of AS over SP there, right? So we can say AS over let me say over AP, let me say AS over SP, so that it can be fine. AS over SP, it will be equal to what? AR over RB. So by proportionality theorem, and also because we know that RS is parallel to BP. Okay, so we can substitute now. AS over SP is AR. What is our AR? Is 3x. What is our RB? Is 2x. Okay, they will cancel out each other. X and x will be left with 3 over 2. So we know the ratio of AS over SP is 3 over 2, right? We can just go back on the diagram and write them. So because we are on this other side, we won't write them as in having x, right? So we use a different variable to show their actual length. So AS is 3. I'm just going to choose y as my variable. It's going to be 3y. SP, this one, is going to be what? 2y, right? 2y. Okay, so from this we can just fill also till here, right? We can also fill till here, because we know that PC is equals to what? To AP, because P is the midpoint, right, of the line there. So PC will be equals to AP, and our AP is what? Is 3x plus, is 3y plus 2y, which is equals to 5y. Can you see? So our PC is just gonna be what? It's gonna be 5y there. Okay, so we can now get the ratio. It's now simple. AS over SC, because everything there has been filled, so we can get the answer. AS is what? AS is 3y over SC. SC is gonna be 2y plus 5y. 2y plus 5y. So this will be 3y over 7y. Y and y cancel each other. 3 over 7. So it's quite, you should also be going back to your diagram and filling those missing ratios or length, right? So that you can be able to just integrate and combine like that, and be able to get the ratios of this. Okay, 10.2.2, determine with reasons the following ratios. They want RT over TC. Let's go and check for RT over TC. Let me just use a different color. RT is this one over what? Over TC. Can you check the triangle in which it is found on, where we can apply proportionality? So the trick thing here is that they will just give you this parallel being here, right? So that maybe you can just think maybe it's also not on that. So this line is still this one, and we can still put that parallel here to say this line is parallel to what? To this one, and this can form your triangle, in which you can form your proportionality theorem, and you can just simply get the answers of those things, right? So you can get them. Or maybe let me just highlight it with the yellow inside so that you can see the triangle I'm talking about. So RT over TC from that triangle, because there's a line drawn parallel to one side of it of that triangle, then we can say RT over TC, it will be equals to SP over what? Over PC. Over PC. By what reason? Proportionality theorem. And we can see also that TP is parallel to what? To RS. TP is parallel to RS. Okay, so it's gonna be very simple. This one is simple because we already have our SP is 2y and our PC is 5y. So you can see that really when you are calculating on previous question, just going back on the diagram and writing what you have already gotten and filling those things can make your work very easy, right? So this will cancel this and you'll be left with 2 over 5 as your ratio for RT over TC. So it's 2 over 5. Okay, great stuff. Here's your fun activity exercise, and let's see who can solve this. So you're given triangle ABC. You're given that AB is parallel to FD, and also AF is parallel to what? To DE. And you're given the ratio FE is to EC is equals to 3 is to 4, and they want you to get the ratio of EC is to BF. So just pause this video, look at this question, spend your time. It can take a little bit of time to try to figure it out. Don't be at rush, and just be after. If you get some of the length, just go back on your diagram and label so that it can be easier for you to connect and to see how you can go about getting the final answer. Okay, great stuff. This marks the end of our lesson today. Don't forget, we were doing Euclidean geometry. This was our session 1, where we were focusing on proportionality theorem, and we also did its converse. I also showed you how to prove proportionality theorem. We also did its converse. We also did midpoint theorem and its converse, right? So just make sure that after this session you just go and try to look for past papers, right? For past papers, and just try to solve those different problems of that include proportionality theorem, so that you can get this wide variety of knowledge that can really help you to master Euclidean geometry and get quality results on your final examination. Okay.